So yeah, we use fat as a fuel, but in terms of carbohydrates, we use glucose as our primary go-to fuel. And it's used a lot by the brain. It's used in tissues like the muscle. But interestingly, it requires a hormone of insulin to move the glucose from the blood into the muscle. But there's less need for insulin in the brain. The brain, a lot of the brain can use glucose without insulin. So when you become insulin resistant, there's less glucose going to the muscle, so there's more glucose that can go to the brain. Basically, it allows the glucose to build up in the blood so that there's more for the brain. Many animals will use fruit as a mechanism to start increasing their fat. And this is known. The bear, for example, can eat 10,000 grapes in a day in the fall, and it goes from kind of tightly regulating its weight to gaining 8 to 10 pounds a day. You have to know that the main nutrient in fruit is fructose, and that's a sugar. It's sort of like glucose. It's distinct from glucose. It's much sweeter. What we've discovered is that when fructose and glucose are together, then suddenly you have something that people love, and that was the discovery of sugar, table sugar, sucrose, which is a fructose and glucose molecule bound together. And then in the 70s, they discovered that they could make a sweetener from corn called high fructose corn syrup, which is a mixture of fructose and glucose. And then, of course, there's what we call those high carb foods like potatoes and rice, and they have starch, they don't have sugar, so they don't have fructose in them. But what happens is these foods have a lot of starch and they break down to glucose. The question was, could fructose be a nutrient that activates the switch that makes you want to gain fat? So we took lab mice, and we put fructose in the drinking water. And by God, they loved the drinking water. They were drinking a lot. For the first couple of weeks, they held their weight stable because they were still regulating their weight. And then something changed, and they suddenly lost their control of appetite, and they started eating more and more. They exercised less and less. Metabolism dropped. And what happened was they became fat. Let's just see if it's taste. And so we took mice that had lost their taste because of a genetic manipulation. And then we offered them fructose or water. And, if they can't taste, you would think that they wouldn't care. But guess what? A mouse that can't taste can still figure out where the sugar is. And it will take the sugar water just like it will a normal mouse. So the desire for sugar water is independent of taste. And they will still get fat. If you give them sugar water, they still get fat even though they can't taste it. If you block their ability to metabolize fructose, and we can do that by blocking the enzyme, and I call that enzyme KHK, and when you block it, we call it a knockout. So these mice can't metabolize fructose. Well, when you can't metabolize fructose, guess what? They don't care for fructose anymore, and they don't get obese even when you force them to eat the same amount. So there's something about fructose. They crave it even though they can't taste it. And it's something to do with the metabolism of fructose.
Annotated and summarized. Easy to share with loved ones. The description below the title for this video has these summary points.
From the website doctorstotrust.com, you can view the summary notes and share or print the PDF of those notes.